Did it record? There it is. All right, this is what we would call general form. General form is not particularly useful for us if we're looking for the center and the radius. So we got to do some work to put that into standard form. So just like we did before, what we're going to do is rearrange a little bit. So I'm going to take the x squareds or the x terms. We're going to put those next to each other. So I'm going to write x squared. And since that's a positive 14x, we'll do x squared plus 14x. You're then going to do the same thing with the y terms. So I have a y squared and a negative 10y. So we're going to put this as a positive y squared minus a 10y. The poor 55, he is not an x or a y, so he just kind of does his own thing. Nobody to add to him. He's just going to stay by himself at the end. Now what you're going to do, take these x terms, and we're going to create a perfect square trinomial out of this. So we need to leave a little space to add in that third term that we're creating. You'll do the same thing with your y's. So I'm going to do y squared minus 10y. Close that, but leave a little space in here for that third term that we need to add. And then we still have that plus 55 at the end. And then all that's going to equal is 0. Okay. I'm going to draw the box. I'm going to expedite it a little bit. We should hopefully understand that this is your x squared. And if I have 14, that means I'm putting how many in each of these two boxes? Lily? 7. So we have 7 here, 7 here. So that means this box should have been a 49. To make this a perfect square, you would be adding 49. Like I mentioned with the one from the homework, there is no 49 in this problem. We just made that up to make a perfect square trinomial. So to account for the fact that that has been created, we're going to subtract 49 because really a positive 49 and a negative 49 is a 0. We do the same thing over here. If we do our little box, you're going to have your y squared here. The negative 10 would have been split evenly with a negative 5 and a negative 5. So to make this a perfect square, this should have been 25. So that's what we're adding here. That's what we are subtracting from the constants. The next step should largely be in standard form. We'll have one little extra part, but now we take this and then now use this square model. And what I have is an x plus a 7 and an x plus a 7 multiplied by each other. So I write that as x plus 7 squared. And then we add the y version of this. So this would have been a y, and then I would have had a negative 5 and a negative 5. So this is a y negative 5 and a y minus 5 created this. So we write that as y minus 5 squared. Add up all these constants. Ooh, what is that? Negative 31, right? 6. No, negative 19. Negative 19, yeah. All right, so negative 19 would equal that 0. Remember when we did all these, like the one we just did here, that constant we want on the right-hand side of the equal sign all by itself. So that's what we do here in this last step. Add that 19 over so that he is on the right-hand side of the equal sign all by himself. And then now this version should make this easy. If you thought number 1 was easy, once you look at this should now be equally easy. The hard part was getting into this step. All right. Once we are at this step, though, now we see our center. Omar would have been what now if we look at this? Good. Negative 7 and a positive 5. So you're going to plot that point. So negative 7, positive 5 is right. Whoa, what happened there? Try that again. So negative 7, positive 5. And then our radius, since this is your radius squared, should be a root 19. If you were to graph root 19, we don't really know what that means. All right, what is root 19, Omar?
4.4.
Yeah, a little more than 4, about 4.5-ish. She'll go 1, 2, 3, 4, and then about halfway past that one. 1, 2, 3, 4, a little over half, and then half, and then half. And then we can sketch that guy in. Okay. All right, so we've now done 2 of these today in the last 10 minutes. So now I want to give you a few minutes. All I want you to do in that third one, we don't have to worry about graphing it, do what we just did. Although, hold on. Let me change this for you real quick, so don't move on. Go to this guy. Let me not make this too hard for you. Take this guy right here and make that a -4. Let's keep this nice. So make that a -4x. And then see how far we can get with this one. See if we're catching on to this. Yep. Yeah, good. So I like all of this here. What you have to keep in mind is at the very end we have the -4 before your equal sign. So when you create this 4 kind of out of thin air, correct. And then that's what you now need to simplify the other side. Okay. Go down here. Yeah. So we can't take the square root of negative one with the imaginary eyes and so there we go. So just also have this. You will add one here, yes, to make that perfect. And then those are what we then have to subtract away. All right, we're pretty close, pretty close. Okay, so most of us are rearranging these good, getting the x's together and then the y's together, and then that 4 just hangs out at the end. So these are our x's in order, these are our y's in order. With each of those, now you're going to create that perfect square. All right. So this guy, I see most of us drawing this, which is good. Some of us are getting away from that, which is also fine. X squared, that -4, you would understand, is split up with a -2 and a -2. So that means I had x and x here. Each one of these had to be a -2. So those multiplied together, giving us a perfect square of a +4. Okay. When we now do that, if I just added that 4 out of nowhere, we're going to subtract 4 as well. If I do the same thing with the y's, the y here and a y here, it gives us the y squared, and then those two y's get split up evenly. That tells us that this was a y plus a 1 and a y plus a 1. Those multiplied together are just a 1. So that means I'm going to subtract a 1 from that 4. Okay? So this guy here is just this x minus 2 times an x minus a2. So we're going to write that as x minus 2 squared. This one here we wrote as y plus 1, y plus 1. So that becomes a y plus 1 squared. When we combine these, this should have given us a negative 9. And then our final standard form step is to take that negative 9. You would have moved him over by adding it over. This is your standard form. Okay? You got it. Then we're kind of remembering all this. A lot of steps. All right, some old stuff. And then now I could ask you what the center is. We know it's 2, negative 1, and our radius would be a 3. Okay? Okay, so we hopefully have those down. Now something a little new here. Make us think a little more. It says, find the equation of the circle in standard form whose center is a negative 6, 2, and then passes through the point 1, comma 2. So part of this is really easy. If I know the center of the circle is a negative 6, comma 2, then we could get a lot of this done already. Because if this is a negative 6 for the center, that means I would have x plus 6 getting squared. And if the y coordinate is a positive 2, I could do y minus 2 squared. So the left-hand side, you're given everything you need to write the left-hand side right off the bat. Our issue with this, just a little bit different way of testing you on what goes over here. All right, so we should understand this is your radius getting squared. There's different ways you can do this. I think for most people, a nice little graph is probably the safest and easiest way to go about this. So make a little XY plane and let's plot those 2 points. So I'm going to plot negative 6, 2, 2, 3, 4, 5, 6. So here's a negative 6 and then a positive 2 on the y-axis. So that point is right here. That's the center, all right, that you're just given. That's why we know the left-hand side. Well, my circle also has to go through the point of this 1, comma 2. So I'm going to come over here to 1. I also have to go through this point right here. All right, well, if this is my center, if I draw in a circle with a radius of 1, is there any chance we're going through this point right here? No. So I need to draw in a circle so that this is, oh, I didn't want to erase that. So that this is the center and the radius goes out to this point. And then I would draw in a circle that has that radius all the way around. So your radius is simply the number of steps I need to take from the center out to the point that we have to go through. Okay? So nothing crazy there. And with the graph, this should be nice. So let me make this nice and big. Let me finish labeling the x-axis so that it's pretty obvious. So if I am right here, I need to go right 1, 2, 3, 4, 5, 6, 7 steps. Okay? If we understand that, that is just a different way of now identifying what your radius is. So we go to the R, and we now know our radius is a 7. Okay? So nothing crazy, just a different way of kind of presenting it, making you kind of understand how to put it all together. All right? And then the last one. Same thing, or not same thing. Similar in the sense that I want you to write the equation of a line in standard form. This one I don't give you the center though, so we can't jump right to that. But I am telling you I give you the endpoints of your diameter. So again, I would absolutely draw this in, kind of sketch out what this looks like. So draw in a XY plane. And then go out to the point 9, 5. And we're going to plot that point. So just plotted that point there. All right. The other point that we want to plot, that is the endpoint of your diameter, is a negative 3 comma 5. So now let me mark over here. So -1, -2, -3, and then 3 comma 5 is going to be right there. Once we have those plotted, what I am telling you is those are the endpoints of your diameter. So some more vocab, stuff that we've been quizzing on and doing here now for the last couple of weeks. So this is the diameter of your circle. So with that in mind, that should allow us to figure out a few things. The center and the radius should be able to get identified from that information. So if this is your diameter, think about the diameter of a circle. So let me come up to one of these that's a nice graph, if we have one already. All right. If I drew in the diameter of this circle from here to here, isn't the very middle of your diameter the center of your circle? So it would be really, 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 really nice if we knew what point was in the middle of the endpoints of your diameter. Okay. Even if I drew in our diameter as a diagonal in this one. Well, the midpoint is the center of your diameter. So what we really need to know is what is the center, or what is the midpoint of this diameter. Find that. So find the midpoint of this diameter. And there's a couple different ways we can go about it. All right, Mo, you kind of had your hand up there for a second. What'd you get?
Is it 6 or 5?
What is it? What'd you think?
I think 6.
So by midpoint, we want both the X. Oh, I know what you did. So here's what I think he did. He understood that to go from a -3 all the way over here to 9, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 steps. So directly in the middle would be how many steps, Mo? 6. So let's do that. So let's start with this dot and let's take 6 steps. So here's 1, 2, 3, and I'm just lining up down here, 4, 5, 6. So this dot right here should be directly in the middle. If we now look at that dot, we should be able to identify what point this is. It has an X coordinate of 3 and a Y coordinate still of 5. Okay. And if we know that, he actually kind of gave us the radius here. Isn't the radius then the 6? That's how many steps we would take from the center. We now know our center is 3 comma 5. And if we know that, we can then very quickly write the equation of our line as this. Now, if this is a diagonal, which I will give you at some point over here in the next few days, remember how we had a midpoint formula? If it's not a nice horizontal line, then we need to remember this guy, where we just add up the x's and divide by 2, add up the y's and divide by 2. Watch what would happen if we did that. Our x's are 9 and -3. So let's plug in 9 and -3 for the x's. And then if I go to my y's, those are 5 and 5. So we'll put 5 and 5 into the midpoint formula. And then, not coincidentally, you get 12 divided by 2, which is 6. I'm sorry. Uh-oh. What did I just do? Oh, -3. Sorry, that's a -3. So we get 6 divided by 2, which is the 3 that we had by just counting with Omar. And then we have 5 plus 5 is 10, and then half of 10 is a 5. That would also give us that same exact midpoint, which is what you would need to do if it's a diagonal. Okay? Okay. I want you to try a couple more of those. Not a lot. Thank you. Oh, you forgot it.
Yeah.
You said it was no or something. Yeah. I thought you said it. I thought it was Wednesday for a second.
You saved those for me.
Yeah.
No, I forgot it was. Hey, that period went by really quick.
Lily, you want the good news or the bad news?
About what?
About